ground starts to quiver, glasses rattle. Soon, walls shift and everything begins to collapse. Telltale signs of what could be a devastating earthquake. We've seen the destruction they unleash. Some of us may have even lived through one. And we know they can be deadly.
Greeting audience, I am sure by now you understand what a earthquake is and the sheer destruction it's capable of. Statistics from WHO says that between 1998 to 2017, earthquake caused nearly 7,50,000 deaths globally. More than half of the deaths were related to natural disasters. More than 125 million were affected by earthquake during this time period, meaning they were injured, made homeless, displaced, or evacuated during the emergency phase of disaster. Unfortunately, there is no technology yet to prevent earthquake. However, it is in our hand to act fast in time of emergency to save countless lives. And to bolster earthquake detection and response system, we are proud to have Arduino earthquake detector, a design by effort of Path Varnekar, Aryan Samant, Rajiv Shah, and Chaitanya Dumala.
We begin by reviewing the component list. First, Arduino Uno. It is symbolically referred as the brain of our product. It is a 5-volt microcontroller with 14 pins for input and outputs. Second, ADXL335 Accelerometer. It is a piezoelectric transducer that converts vibration forces into electrical pulses. It reads inputs from all three dimensions. Third, breadboard. It is a working base and allows temporary circuit build-up. Fourth, LCD screen. LCD screen is used as a visual output channel. The LCD screen here is 16 by 2, where the 16 refers to the number of characters per line and 2 refers to the number of lines. It shows us calibrating or danger alert. Fifth, buzzer. It is our output device that plays a major role in alerting the audience. And lastly, jumper wires, which are used for connecting the circuit. Let us now understand the built-up and the working principle of our product. Moving forward, let us understand the circuit diagram as well as the working principle of our product. As you can see from the circuit diagram, the accelerometer is connected to Arduino for pins X, Y, and Z. The Arduino Uno is then further connected with the LCD screen as well as the buzzer. The Arduino Uno is provided with a 5-volt power from the monitor itself. Here, as you can see, there is a small LED light that helps to detect if there is any error in the circuit. The light will only glow if there is any error that occurs in the circuit. Moving on with the working principle. As you can see from the circuit diagram, the accelerometer here acts as an input device. It converts the vibrational forces to electrical pulses. These pulses are then transferred to Arduino Uno, the brain. Arduino detects and processes this data type. The Arduino consists of a command that sets a threshold limit to incoming value of data. That is, if the data is more than the threshold limit, the alert system is activated. The buzzer starts to beep. Else, the system resets into the loop. Lastly, let us look at the demonstration of the actual product.
Now that we've understood the hardware aspect of our project, let us now understand the software that makes the system work. So first of all, we include all the necessary libraries that make our components work, like here the library for the LCD display, and define what pins are connected where in this region. Then we go into the setup loop, where the accelerometer is calibrated using this for loop, and upon completion of this calibration, the system is now ready to work. So when there is a disturbance or tremor, The accelerometer measures the x, y and z displacements, and using the if loop, which is here, uh, the buzzer goes off along with the LCD, giving the alert based on the condition of buzzer being on, and also displaying the XYZ values right here. This occurs when displacement in at least one axis exceeds the range of values that are defined by us right here. This if loop only works when the displacements go above what we have defined, which is the tolerable range. So after that, this loop will continue repeatedly until the earthquake or vibration cease, giving us constant alert and caution. So now that we've understood the software and how the software makes the system work, let us now understand the importance of earthquake detector and why our system in particular stands out.
Now, let me present in front of you points to showcase the necessity of our product. Earthquake detectors provide advance notice of impending earthquakes, giving people crucial seconds or minutes to seek shelter and protect themselves. By alerting people before earthquakes strike, these detectors significantly reduce the risk of injuries and fatalities. Detectors help emergency responders identify areas most affected by the earthquake, helping them prioritize rescue efforts and allocate resources effectively. Our cost effective, simple, versatile, and portable earthquake detector can be attached to home walls, factories, and civilian infrastructure and can play an important role in alerting civilians of the upcoming calamity. Our product stands out as a cheap solution as an alerting system in earthquake prone areas where infrastructure is under equipped, like in villages of Uttarakhand in India. Its simplicity means mass production is also easier. So, in conclusion, we believe that our product is the perfect solution to respond to nature's calamity that we cannot control, helping saving lives at a negligible cost, making communities safer and stronger. Thank you.